Hello! In this video, I will give an overview about the acceleration of next-generation systems using FPGAs in combination with the automatic design tool Veltronix Accelerate. Today, I will focus on the benefits of hardware acceleration and introduce Accelerate. Accelerate is an automatic design tool developed by Veltronix that generates a customized hardware accelerator from a software task. The generated accelerator has the same functional behavior as that of the software, so that your application executed in software will give you the same result as the accelerator executed in hardware. The generated accelerator, which comes out in the form of Verilog RTL, can then run on your hardware target through logic synthesis. Why would you want to do hardware acceleration? Running your application in hardware rather than software can bring you higher data throughput as well as shorter calculation execution times. When you need to make your software task run faster, hardware acceleration may be the way to make this happen. Common applications where hardware acceleration can bring performance benefits include machine learning, control systems, image and video processing, network acceleration, and cryptographic acceleration. Due to various factors, the requirements imposed on embedded systems has been on the increase. Execution speed requirements are becoming stringent in many applications, such as high-speed motion control, high-frequency trading in financial markets, and computer network traffic processing. The amount of information to be processed is rising too, for example in applications such as image or video processing and big data. Thirdly, with new algorithms being introduced in various fields such as image processing and radar, the functional complexity of applications is rising. In order to meet these rising embedded system requirements, Accelerate can do the following for you. Accelerate can generate a hardware accelerator for your application that reduces calculation execution times and increases data throughput. It applies advanced optimizations and parallelisations to reduce complex applications in order to achieve your execution time and throughput requirements. It also does the resource allocation, calculation scheduling, and pipelining for your hardware target. To show the benefits of hardware acceleration, I will use the example of accelerating a motor control algorithm. In this example, a reduction of execution time by a factor of 141 was obtained, comparing execution of software on an 800 MHz ARM core and execution of equivalent hardware on a 250 MHz FPGA. What made this performance increase possible is the combination of features of Accelerate and benefits of FPGAs. Accelerate is well suited to applications that have large amounts of parallelism and tight latency requirements. FPGAs can be programmed to perform calculations in parallel and to do specialized calculations that general-purpose hardware such as CPUs are not well suited for. Accelerate can also improve upon existing RTL development processes that involve manual RTL accelerator design. The diagram on the right illustrates a typical RTL development process. A function specification is derived from the requirements of an application. The functional specification may be C code, or it may be in some other format. The output of the design stages is synthesizable RTL for a hardware accelerator, which may be in Verilog, VHDL, or some other format. The RTL goes through logic synthesis, which is followed by timing verification to check that the synthesized result satisfies target hardware timing requirements. RTL development processes that involve manual RTL accelerator design typically have the following issues: long development times or high manpower costs, the design stages being prone to mistakes, troubleshooting of the RTL being painful, and the inability to change the target hardware. Accelerator can majorly improve upon existing manual RTL development processes by automatically generating the accelerator. This automatic generation can cut down development time and manpower and allows the developer to do development in a software environment. Also, Accelerate generates a hardware accelerator that is guaranteed to behave functionally in the same way as the software, therefore eliminating the possibility of RTL bugs and eliminating the need for troubleshooting. Optimization and parallelisation are performed on calculations automatically, rather than having the developer optimize and parallelize their design manually. Automatic generation of the hardware accelerator brings flexibility in the following ways. Firstly, an accelerator can easily be regenerated for a different hardware target. Secondly, by regenerating the accelerator, design exploration can be performed to find a design that is optimized with respect to desired metrics, such as execution time, throughput, resource utilization, and power consumption. The following features make it easier for users of Accelerate. Accelerate supports a subset of C99 ISO compliant C code. The benefit of this C language compatibility is that C is widely known among programmers and engineers. There is no need to learn a new language that is specific to Accelerate or hardware design, which makes Accelerate friendly for software engineers or for other people who are not experts in hardware design. One thing that makes Accelerate different from some other high-level synthesis tools is that Accelerate doesn't require the designer to annotate their C code with hardware-specific pragmas or comments. Only minimal or no modification to the original C code is required. Accelerate has two front ends that a user can use: a graphical user interface and a command line interface, both of which are simple and easy to use. The RTL that Accelerate generates has the following features. Accelerate produces an efficient accelerator with low execution times and high data throughput through optimization and parallelisation. Operation scheduling and resource allocation, both of which are steps required in hardware design, are done automatically. The generated accelerator shares hardware resources between commonly occurring operations in order to reduce resource utilization. It's worth noting that the extent of parallelisation and resource sharing can be adjusted by tweaking Accelerate's parameters. This ends my explanation of the overview of hardware acceleration of next-generation systems using FPGAs and Accelerate. At another time, I will demonstrate how to use Accelerate. Please feel free to contact us if you have any questions about Accelerate or anything related. Thank you for listening.